So hi everyone, I welcome you once again to Dynamic Coaching Center. So it's yet another video on the radiation mode of heat transfer, and we'll be just continuing with the problem so far whatever we have seen. And those who are actually new to this particular video, please do check with the previous videos which I have made, where you can understand the few basic concepts related to radiation mode of heat transfer, and then come back over here to understand these kind of problems. You will be in a better position to solve this. So here's a question which has been asked in the year gate 2018 afternoon session, right? So the peak wavelength of radiation emitted by a black body at a temperature of 2000 Kelvin was found to be 1.45 micrometer, right? So the wavelength value has been given, and it is given as peak. So this is a very important thing. So the maximum wavelength and its corresponding temperature has been given, T. So these two are actually related together by something called as Wien's displacement law. So if you remember that Wien's displacement law, then we'll be able to correlate or connect with the two data given in the question. The maximum or peak wavelength multiplied by its temperature should be equal to a constant value, and that is equal to 2.898 into 10 power minus 3 meter Kelvin, right? So it is said that the peak wavelength of the emitted radiation, if it changes to 2.90 micrometer from 1.45 micrometer, then the temperature in Kelvin to corresponding to this wavelength, what would be the temperature? T2. That is what been asked as a question, and if this is kept as T1, right? And let us keep this as lambda 1, and let us keep this as lambda 2. So for the first case, the wavelength and the temperature lambda 1 T1 has been given, and for the second case, the wavelength lambda 2 has been given, but the temperature is what they are asking as a question, and they have clearly mentioned that it is a black body, because we know that Wien's law can be applied for a black body because it is nothing but the extension of your Planck's law, right? So option A, it is 500 Kelvin, option B, it is 1000 Kelvin, option C, it is 4000 Kelvin, and option D, it is 8000 Kelvin. So this is a straight back 1 mark question. These kind of questions you can expect in any of the competitive exams, right? And without the usage of calculator, you'll be able to do this in a matter of time. So we'll just get into the solution part. So these are all the given datas, the first wavelength of the surface and the second wavelength, and corresponding to the first wavelength, the peak temperature value has been given. So according to Wien's displacement law, we can say that lambda max into its corresponding temperature is constant. So I can write my, for the first case as lambda 1 T is equal to constant, and for the second case also I can rewrite as lambda 2 into T 2 is equal to constant. Since both the right hand side terms are equal, I can equate the left hand side terms, which is lambda 1 T1 and lambda 2 T2. So lambda 1 multiplied by T1 equal to lambda 2 multiplied by T2. So lambda 1 value is known, T1 value is known, lambda 2 value is also known. So just by rearranging, we'll be able to find out the T2 value, and it is coming around as 1000 Kelvin. So if you just get back to the options, I can say that option B is the correct answer. Hope you might have understood this. We'll just move on to the next question. So here is the next question. This question was asked in the previous year 2019 set 2 afternoon session. It's a straight back 1 mark question problem, and sphere 1 with a diameter of 0.1 meter is completely enclosed by another sphere 2 of diameter 0.4. So we can say that these are concentric spheres. So both are having the same axis, but two different spheres, right? Concentric spheres. And the diameter of the first one is 0.1 meter, and that of the second one is given as 0.4 meter. So let us take the inner sphere to be 1 and the outer sphere to be 2. So they're asking you to find out the view factor or geometry factor of the first one with respect to the second one, right? So F12 is what they have been asked as a question, and option A is 1, option B is 0.0625, option C it is 0.25, and option D it is 0.5. So as I said that these kind of questions often try to occur in most of the competitive exams, and you can even note down one thing that so far we have discussed gate questions, and even in those videos also you can find these kind of questions often getting repeated as far as radiation topic is considered, right? So we'll just move on to the solution part. So as I said, first try to convert the given question into a diagrammatic representation, and this is the first sphere and this is the outer sphere which is numbered as 2, and these are all the two diameter values given as data as D1 and D2. D1 measures to 0.1 meter and D2 is 0.4 meter, and right from the diagram we can easily say that since the first surface is concave, fraction of heat leaving from the first surface and falling on the same surface will be equal to 0, right? So applying the summation rule for the first sphere, I can say that fraction of heat leaving from the first surface and falling on the same surface plus fraction of heat leaving from the first surface and falling on the second surface should be equal to 1. But we already know that since it is concave, this value is 0. So I can say that all the heat which is leaving from the first surface will definitely fall on the second surface. And that is what being asked as a question. It's a very easy one. So option A, 1 is the correct answer, right? So it's a very simple question. Hope you might have understood this. So with this we have concluded the 1 mark question so far asked in the gate question papers related to radiation mode of heat transfer. So only topics which has been left out is the questions from the ESE and other PSUs, which will be discussed slowly. So just watch for the videos and try to keep your bell notification so that you will get alarmed for each and every videos which has been posted out here. And as far as the next few classes are considered, we'll be just entering into the 1 mark question of yet another topic, and also related to your gate question papers, we'll be entering into the 2 mark session so far asked in the previous year gate question papers. So hope you might have enjoyed this video. If you like this video, please do subscribe, review, rate and recommend to your friends. And for all those newcomers, please do watch the videos right from the beginning. So I have mentioned this as part 1, part 2. So for your convenience, so try to gather the videos and watch the videos in the same manner so that you'll be always able to proceed on with the next few problems of what we are going to see in the next few videos, right? So thank you. We'll just meet up in the next session. Have a great day.